Okay, welcome back to Calculus 2. We are going to try to figure out the integral of e to the negative x squared dx using the first four terms, okay, of the Taylor series. Okay, so this is a very famous integral. It's called the Gaussian, Gaussian. Okay, for electrical engineers, you're going to see this quite often. For statistics, you're also going to see this quite often. For the people who take the actual statistics class, we have tables that give people the answers to all of this stuff right here. So, but the numbers in the tables had to come from somewhere, and this is where they come from. So what we're going to do is we're going to use the Taylor series for e to the x squared, or e to the x, and replace our e to the x with a negative x squared, and then figure out our answer from there, okay? So going back to what is the Taylor series of my e to the negative or e to the x, okay? So Taylor series, okay, Lord, really, for x. Okay, and we get 1 plus x squared over 2 factorial, but this is technically over 0 factorial over 1 factorial, okay, technically. Plus, we have x3 over 3 factorial. We'll ditch the factorials and reduce this a little bit to make it a little bit easier for us. So we have 1 plus x squared times a half. 3 factorial is 6, so plus 1, 6 over or times x3. Now, this is e to the x, okay? We don't want e to the x. We want e to the negative x squared. So everywhere I see an x, I'm kind of plugging in my negative x squared here, okay? So we're going to say this is 1 minus x squared plus 1 half. And really what's going on here is I've got negative x squared, okay? And then we've got 1 over 6. We've got negative x squared cubed. Okay. So trying to keep track of the negative signs is going to be kind of an important thing here. We end up with 1 minus x squared plus 1 half x to the fourth power. The squared killed this negative 1 here. Minus, because it's cubed, this negative stays here. So minus 1 6 x to the 2 times 3 is 6. Okay, so that's where we are with that. Okay, we haven't integrated yet. So the idea now is we're going to integrate this function from 0 to 1. Okay, so that's our next job here. So we're going to get x minus 1/3 x cubed plus, this is going to go up to x to the fifth. So we have x to the fifth here. So we have 1 over 10. Okay, and then finally we have x to the seventh. And we're going to end up with, this is 6 times 7 here. So that's going to be 42. Okay, so 1 over 42. And of course, we're going from 0 to 1. So if I plug in my 1 here, this is first four terms, 1, 2, 3, 4. So we have 1 minus 1/3 plus 1/10 minus 1 over 42 minus 0. Okay. If you want more accuracy, you get more terms. That's what you do. Okay. So we will be able to go through and do that. Okay. So we end up with, let's go ahead and clear. Okay. So I've got 1 where are we here? 1 minus 1/3 plus 1/10 minus 1 over 42. 42. Oops, I don't want cosine. I want 42. Get back here. There you go. 42. And everything else is deleted. Okay, good deal. Now press enter. And I got that 0.7. This is this is another nice problem to deal with. So point, and then what do we have here? We had point 7429. If the problem says go to 4 decimal places, and it probably will. Maybe 6 decimal places. So we can go ahead and read off 6 numbers for that, but probably 4 decimal places for this one. Okay. So that's how you do a problem like this. This one is incredibly important for all the electrical engineers. Later on, when you guys take some engineering statistics or engineering probability, you're going to be introduced to the error function, which is what this thing is. And it's called the Gaussian, and that's pretty much what we're dealing with. Okay. So very important function for a lot of mathematics. This is how you would integrate it, but you can't integrate it like nicely. So we have to kind of cheat and use our Taylor series. Thank you very much for watching the video. I'll see you in the next one. Take care until then.